before we start, what do you want to build? Give me a few ideas.
An app that tells me how to cook.
What? App? Okay.
Yeah, it does.
Okay. Okay. Okay, I'm building the output. How to cook. But next we'll show you the part about how to build the complicated project, and then I will show you what our flaw built. So it will take like 5 minutes or so. Right?
Yeah. Okay. So one of the cardinal sins of AI Tinkerers is showing slides. But I'm but I do have architectural slides that I want to share with you guys. So the premise of this is like, in the future, what is it going to be like when you can just tell the computer what application you want to build, and it goes off and builds it, and you come back and it's polished software, right? And we're approaching that today, right? We've seen systems that can come pretty close, but inevitably, if you're building complex software, you're going to run into some issues, right, with quality, and that isn't what I meant, and the AI will tell you that it works, but it really, it's lying. It tells you all the tests are passing, but they're not. So I did a deep dive over the last few weeks into software factories, and I'm going to talk more about what I mean when I say software factory. And then we're going to wrap up the talk kind of showing you how we've applied the software factory to the Sundai Club. We've essentially created how would you describe it, Nikolay? Like, it's like an AI hacker that comes. Yeah. Okay, so we're going to talk about what is a dark software factory. I'm going to talk about how you can define and refine specifications using something called OpenSpec. And we're actually going to implement those specifications using another tool called Fabro. We're going to walk through an example project with OpenSpec and Fabro. And then we're going to build our first factory activated with OpenClaw and Telegram. And then we'll wrap it up with some questions. Okay. So just in the last year or so, we've seen a rapid evolution of AI development. And you guys may have seen this post by Dan Shapiro called The 5 Levels from Spicy Autocomplete to the Software Factory. So he's basically like chronicling the evolution of how we have started out with something like ChatGPT, where it's very interactive. You ask a question, and it's basically like a smarter version of Stack Overflow, right? You ask a question and the AI responds with an answer. Then we evolved to like level 1, which is where the AI is writing boilerplate code, unimportant code, but not like your critical code yet. Level 2 is more like a junior developer, right? Where you're doing like pair programming with this junior developer, and you're handing off some control. The human is still very much in the loop reviewing that as it's generating code in real time. Then we get to level 3. This is where the AI is generating the majority of the code base, and the developer is still reviewing everything that the AI is doing. But in this situation, and you may have found yourself in this situation, the human then becomes a bottleneck, because the AI can write the software faster than you can review it, right? And then you realize you got all this code piling up that needs to be reviewed. So level 4, the AI can run for long periods unattended, for hours potentially. And it can do much more complex stuff. And then the human is really trusting that there's like self-checks, right? And you're only really kind of checking the final result. And then the final level, this is the one we're going to talk about today, is where the engineer is really kind of managing the goals, the specifications. It's defining, yeah, question? Where are we today? Well, let's take a poll. Who's in spicy autocomplete? Raise your hand. Who's in coding intern level 1? Okay, we got a lot of advanced people here. How about junior developer level 2? Level 3. Okay, we have a lot of level 3s. Level 4, senior developer. Okay, and how about level 5, software factory? Wow, we got a few factories on this side of the house. Okay. Yeah, so different people are at different stages of this, right? Because this is moving really fast. There's a lot of solutions out there, and it may also be depending on what you're building. Your comfort level may, if you're building like a game, like maybe you're okay with a factory. If you're building like healthcare software, maybe you're closer, to this other level where you want more control and oversight in it. Okay. So there's where I heard about dark factories from Simon Wilson. Who reads the Simon Wilson blog? Yeah, it's a great blog. And he talked about this tour that he got of Strong DM. And their premise is that all code must be written by the AI. So like no code can be written by humans. And not only that, but all the code must be reviewed by AI. Right? And okay, think about that for a moment. All the code is written by AI, no humans involved, and all the code is reviewed by. And so in practical terms, this is like, okay, if you haven't spent $1,000 on tokens today, then your software factory has room for improvement. That's kind of like the idea. So the question that Simon poses, which I'll ask you all, is like, how could it be how could this be possible, possibly a sensible strategy when we all know how prone LLMs are to making mistakes, right? We've all faced this situation, right, where the LLM says that it's done something, and then you look at it and it's like it's completely failed. So I think this is kind of like the holy grail, right? Everyone is trying to figure out like, well, how can you get the AI to actually, when it says that it's done something, that it actually has done something. So we've all heard of technical debt, right? If you've been in the engineering space any amount of time, you probably have experienced debt over time. You have code that goes stale, stuff that changes, but it's still in the code base. Well, now with AI, it's really accelerating the pace of not just technical debt, but cognitive debt. So the engineering team knowing what has been built, but more importantly, the intent debt, which is why has this been developed? Why did this change, right? And this isn't always getting captured. When you're moving very fast with AI, a lot of these decisions are getting lost. And then you're looking at the code base, you're like, well, why did it do that instead of that? So one of the tools that I've been exploring to try to address this is something called OpenSpec. And the best way to describe it is like a lightweight spec-driven framework. And really, the idea with this is that it captures the change in requirements of the system. So this makes it a lot easier for developers to understand how they're modifying the system and what still needs to change. So you can review the spec and you can see, oh, I understand now why we changed the code from this to this, right? And this is like really important when you're moving at AI coding speed, because there can be a lot of changes happening. And if you just let the AI kind of run amok, it can make a lot of changes and then suddenly your code becomes unrecognizable. So OpenSpec is a way to kind of capture all those requirements as you're going and snapshot them and have them in your Git repository. And that also becomes a good resource, not only for humans reviewing the code base, but also for the AI. It can kind of use that as very grounding mechanisms, or like source of truth. It can look at those specifications and know, oh, I can see why we made that change, right? Okay, so let me talk about Sundai. Nikolay, feel free to chime in here. Did you get a microphone, by the way? Oh, you didn't get one? What? Oh, here it is. Here, if you want to put this on. I don't know why it's flashing. It might be getting a little better. Okay, so we took this idea of like OpenSpec and something called Fabro I'm going to talk about in a sec. And we thought, what if we could just tell OpenClaw via Telegram what we wanted to build, and then have an entire pipeline, have the AI checking and validating and doing a lot of the steps that normally humans would be doing, like making the GitHub repo and deploying the software up to Google Cloud. And so this is a 15-step process. I'm not going to go through all these things, but you can see there's a lot of stuff happening here. And at the end of this pipeline, what comes out is the GitHub URL. So it pushes the code to GitHub, the URL on the project page on the Sundai.club website, and a deployment URL, so where the code has been deployed, where you can actually try it out. And then there's some AI verification steps as well to make sure that the software.
Note what Sundai Club is. Sundai Club is a hacker club. We hack every Sunday. So our goal here was basically to replace ourselves with AI. So AI can hack and do everything we do every Sunday by doing. But question? Deal with number 9 there. What is it?
Like.
Oh yeah. Wow. There is a Sundai website with a project, and each project has likes. So bot can like its own project, so it has at least 1 like. It's like liking your post.
It's like the tip jar. You know, if you're a musician, you put like $1 in your tip jar. Let's see if we actually have. I had it in here somewhere. Okay, I have too many tabs open, as you can see. Okay, back to the. Just have like one or two more slides here. So number 2 in this. Why is it saying loading now? Okay. So number 2, which is create GitHub repo and OpenSpec Fabro. This is zooming in on just number 2. Okay. So what Nikolay did at the very beginning of the talk is he asked you guys what you wanted to build, and he typed that into Telegram. Then what happened is that message got sent to an OpenClaw gateway, and on which we have a skill called Sundai project pipeline. That's step 3. And that's that 15-step orchestrator that does all this other stuff, right? That Sundai project pipeline calls the OpenSpec workflow, which essentially distills a full spec from that initial query. So like you just give it a 1-sentence description, and it goes and fleshes out like a design.md and a task.md and a proposal.md and like a whole bunch of other, and for each feature in your application, it builds out a specification. Then that entire spec directory gets passed to Fabro, and we have a special workflow called Sundai ship. And what Fabro does is it takes that task.md file and it breaks it into a graph. And in that graph, we have conditionals, we have loops, we have quality gates, verification checks. So by the time that software gets deployed up to Google Cloud, it's gone through a very rigorous process of like checking the quality, linting, doing a lot of like, looking at the plan and making 2 versions of it, and then synthesizing the best of both plan. There's like a lot of machinery happening. You can see these are all the files that are getting generated behind the scene. So I'm going to hop over and show you guys what's actually going on in the code base. So this is our hacker repo. This is up on GitHub if you want to check it out. What's the URL? SundaiClaw/hacker. Yeah. So at the beginning of the thing, I put in the same thing that Nikolay put into OpenClaw. I just did it on my computer so you can see what's happening. OpenClaw can be a bit of a black box, right? When you tell OpenClaw to do something, this is part, I've been a little frustrated. Nikolay, I think, has gotten a lot more comfortable just telling OpenClaw to do something and trusting that it's gonna do it okay. I like to see what's going on, so I have it running on my laptop. So we have these things running in parallel. He's running it up on the cloud, and I'm running it locally, so you can kind of see what's happening. So here's the learning to cook. So this was where we put in the prompt. Can everyone see this bio, or should I make it a little bit bigger? Okay. All right. So this is basically the same thing that's happening up on our OpenClaw server. It's just we're replicating locally. No. Not right now. right now we've auto approved. We do have some human in the loop steps where it'll pause and ask you, does this specification look correct? Until we can figure out how to make that interaction on OpenClaw like smooth, and also for demoing, it's a little better to just have everything happening automatically. But we do want to introduce those human in the loop so that once it does the first version of the spec, it'll pause and like ask you to review it before it continues. Okay, so yeah. It can run in parallel, but I don't know right now. We haven't really tested this at massive thundering herd.
Yeah.
Yeah.
Practically speaking, like when we tried it yesterday, yeah, it just like waited for while it's building Nate's project, it waited before starting to build my project.
Yeah.
Should I show the
just one? Oh, is it finished already?
Yep.
Okay. Before he does that, I just want to show this is the workflow, kind of what's happening. This is a simpler version of the workflow that I'm using locally. This one is the one on the Sundai Club website where you basically do a planning phase, then there's an implementation phase. Then we install the dependencies. We make sure that all the dependencies install correctly. We run a lint check. We check to see did the lint pass. We build it, and then there's a loop. So it goes, if there's any lint errors, it loops back and fixes them. And if the build fails for any reason, then it goes back and it kind of self-improves. It basically loops back on itself, and then it'll just keep debugging until it gets everything to pass. Do you want to show something?
Yep. Wait.
Do I need to admit you? Vyahhi, do you know if he's...
No, I'm sharing.
Oh, you are sharing? Oh, maybe I need to stop share.
Maybe.
Okay, try now.
And you... Yeah. So actually I skipped Fabro because it takes like 10-15 minutes and we don't have this time. So it just like tried to build an app with AI model itself. So this is a Sundai card. Actually, it experienced some issues with Sundai website. So it's not like Sundai card is not fully working.
Nobody put a full description there.
Yeah, it missed the description and link. But it built so I asked it, build a new Sundai project, keep Fabro, app that tells me how to cook based on someone's idea. And it started building. It built a GitHub repo for this app. It wrote spec with OpenSpec. Then it struggled a little bit with some coding issues. Then it tested, verified, deployed to GCP. So this is our cook compass. And dinner helps start when you're, what does it do? I don't know.
You picked the recipe, it looks like.
Yeah.
I have egg. Oh, you could say what ingredients you have.
We'll see. So it builds an app, basically, that uses AI. It uses a free open router endpoint here. So we are not running out of credits, but it's kind of stupid. And what's going on? Who understands this interesting UI?
Idea generation.
Wait, I pressed find my.
This is what happens when you give a one-line specification.
Yeah.
It just kind of goes and builds random stuff.
Yeah, probably like also if it used Fabro, it would be.
Yeah, if it had used Fabro, we probably would have gotten a better.
Yeah, but huh? How many tokens did you use? Oh, we don't know. But we used our friend's OpenAI key.
Yeah.
With lots of credit, so I hope not much. But overall, this Sundai, it's a pipeline. It's a skill for OpenClaw that creates Sundai projects from GitHub repo, deploying, create a Sundai page based on human request or randomly. So I usually also create some random projects. Today I created the AI Thinkers website, and it hallucinated our schedule for today. Kind of looks similar, actually. Yeah, some other projects.
I was going to show the skill that actually does the work, if you don't mind stopping sharing.
Yeah.
Okay. So this is the actual skill.md file. So you can see it's quite involved in terms of like instructions and step 1, phase 1, phase 2, phase 3, and the OpenClaw agent is basically following this, not religiously, but it's following it as close as it needs to deliver the final thing. And we found that it's pretty smart about, like, if it reaches a block, it'll kind of find another way to do it, which sometimes means skipping some steps. Which so there's still some room for improvement here. But this, I think, didn't you say that the hardest part was just getting it to be able to post to this? Like, it wasn't building the app; it was getting it to post to the project page. That was like the most complicated piece.
The Sundai website doesn't have API, so it tries to click buttons. And, it's harder than building a software for AI.
Yeah.
Yeah.
And then you have that you were showing earlier.
Mm-hmm.
That was a Fabro.
I think it's Fabro.
Yeah.
Fabro.
Yeah. Yeah. So actually one step out of this 15 is use Fabro.
Yeah. But that right.
Yeah.
Right. That's all fine. Fabro. Cool.
Yeah. So these are the artifacts that get created. Actually, that's not the cooking one. We get to the.
Maybe we can.
Yeah. While I'm pulling stuff up, we can take some more questions.
There's a lot of controversy about
sometimes
to do procedural operation.
Sometimes, not always.
Okay.
Sometimes, but yeah, it needed some prompting around the steps.
My second question is, it's obvious to get a design agent. So, where do you think the main points are when you go to conclusion? Where why now?
Yeah. So there's obviously like tests. If you look at this, this is like. So this is another workflow that I asked Claude Code to build. So Fabro has a skill called create workflow. So when you have like a code base, you can tell Fabro to go create a workflow specific to any particular thing that you want to automate. And so I told Claude Code, use the Fabro create workflow skill to create a workflow for doing browser testing. Because I found it was very annoying to have to like open up the browser and click on stuff and then tell AI that something was not working. So this is a workflow that it came up with for a game that basically like runs various test suites, visual verification, gameplay control, scoring of progression. It collects all the results, and then it checks do all the tests pass. And if they do it, it generates a pass report. If they fail, it generates a fail report, and then it exits. So this is an example, Andy, of like how you can provide some like end-to-end browser testing that once you give the AI access to your logs of the front end and back end server, and you give it access to a browser, it can sort of self-heal. It can like figure out, oh, I can see in the logs here, I'm getting this error, and then it can see in the browser where things are breaking, and it just iterates until it fixes it.
Not necessarily. Some of these steps, like a deployment, then adding links, like publishing on Sundai Club website, adding links or the GitHub, the Sundai project. Those some of them are like logistic, like steps in building Sundai.
But I'm super maybe over this so that I have like 9 out of the 15 technical aspects.
Yeah, it does stuff.
I would use it.
Yeah, sometimes I take screenshots and like trying to understand whether like still something works well and looks good and so on. Yeah.
I think something that has helped in what I showed, I had the same issue where tool calls are out of order or some things are not happening.
Yep.
I think what helped in what I did was using something called structured output and then having it more deterministic steps there so that it goes through X, Y, Z and not Z, X, Y.
For us, what helped is basically repeat like steps multiple times, and also we have the skill of 15 steps, and also the separate checklist, the checklist that basically have most of the steps, and last step on a skill is to use checklist and verify that everything is done. So it's been like multiple parts of the skill asks AI to stay on track, do everything, and check that every box.
I just wanted like people to have the does it help to even run this using cheaper models?
Cheaper model doesn't do well with OpenClaw in general, and with like one. So it's like so for example, I think Minimax was a little bit worse. So it's the GPT 5.4. But yeah, like free model, free other models like didn't do it almost like anything. Like Minimax works sometimes. No, it's more like more tool calling and overall intelligence. It's not a complex type because it do multiple calls. Like it can like do sub process, sub agents, but overall intelligence and tool calling. So lots of that.
My question is about the backtracking. What kind of different sources do you use to give back the agent whether or not it's doing the right thing? Like Nate mentioned linting, I mentioned tests. Nate then also mentioned that it has like a solved or like a what's called a playwright skill where it's outright the browser. What sources do you have and why are they? Which ones are?
We don't do much, but we ask it to make sure you're correct, verify yourself, something like that. So it's not like
Pretty.
yeah.
I wanted to mention that Fabro has a kind of experimental web interface. This is all dummy data right now, but if you go to the GitHub repo, you can try this out. So this is basically taking all the command line artifacts that are created and try to visualize them. So these are all my sessions that I have, like just chat sessions with the, oops, that one is not working. These are the different workflows. So each of these is represented by a diagram. So you can see, you know, kind of how it diagnosed the root cause, it applies a fix, it validates, reviews the changes, implement feature has a different workflow graph. Well, it actually looks the same. And then these are different verification steps that you can specify.
It's hard to measure. How do you measure things?
How do you measure what?
Phase. Yes. Yes. So
What?
we have ideation phase, like a first one, and you can also pick the idea randomly. And what it does, it takes best like Sundai projects and like have some inspiration on already existing projects on a Sundai club. So since we, as a hacker club, like that project, maybe like we will like the new one. But overall, it's not very sophisticated ideas.
Yeah, some of the improvements are like adding UI UX skills. So there's some there's this one called impeccable, which is like design fluency for AI harnesses, is how they describe it. So it has like 20 different design skills. And if you add this into your Claude Code skills directory, which we can do with Sundai Claw as well, suddenly you've just, it's like, I know Kung Fu. Now suddenly your coding assistant now knows how to write, how to make designs, and they don't all look the same as, like, you notice that the last few, the apps that we built all kind of look the same. So that this gives you, it gives your AI like better design aesthetics. And
in the middle, I think since underlying models and tools are improving, in a year, the same Sundai Claw, like even without any change, will build much better, tasteful product. Do we have more time?
Okay, this might be answered by the Fabro traces, but how have you thought about actions where
how to capture what?
where
Yeah, so it is creating an incident log. So as it's going through the workflow, whenever it encounters an issue, it logs it to a markdown file. And then you can feed that markdown file, well, also JSON, it has like JSON-L files. So you can feed that diagnosis report back in to the build or the implementation phase. So it'll just keep iterating until it's resolved all the issues in the list. I think we may take one or two more questions.
So,
Okay.
so Fabro, I think, is like a deterministic graph behind it that controls its flow, and your kind of whatever 15-step process will kind of more like LLM-driven workflow. I'd be curious what your experience is between those, and like where you see the strengths, weaknesses. Like you said, it might self-heal better, but then it skips stuff. Like, yeah, where do you see that balance? Where do you see that?
I think we're kind of like differences made. So I did on the LLM side and just give it tools, give it loops, and they'll figure it out somehow.
I'm a little bit more on the deterministic side. He's more on the just throw it over the wall and let the AI figure it out.
Yeah, I think for software development, Fabro works great. For less deterministic things, like you need less deterministic. Yeah, but there's no silver bullet here.
Yeah, so these are some examples of like the logs that get generated when you're running Fabro. So it's showing you sort of, it's checking all these different things like correctness of the different API endpoints, security, it's doing a bunch of security checks, simplicity, completeness, consistency, and then it documents any changes that it makes as well. And this is an example of like an implementation log where it tells you what files it created, the source files, the front end, the tests that it created, any issues that it encountered. So.
I'd love to understand if you guys have experience maintaining or iterating on, spec-driven Fabro built applications. What's that like? What part of the system do you touch when you want to change something? You just want to change one component. Is it spec? Is it a component in the code? Or is it?
Yeah, so the way OpenSpec works is you type in OPSX OP propose. If you want to like brainstorm, you do the explore, and then that kind of launches into like a Socratic thing where it'll start checking your assumptions and asking you questions and try to refine and figure out the shape of what you want to build. If you really know what it is you want to build, you just do propose, and you just tell it what it is you want to propose or what you want to build. So I would say something like add a cooking timer feature, right? I think because it's doing this up here, it might not also let me propose a feature at the same time. And then those new specifications will get defined over here in this changes folder. So you see I have changes, and this was the original specification right here, right? So this was the proposal. My screen is kind of tiny. Sorry. I can't show you that right now. But basically, as you define new features, they'll show up here with the timestamp. And then when you tell it to go build it, it knows what it's already built, and it'll just kind of pick up where it left off. So you can see it's.
You change the spec and open give you can pass it.
Yeah, and because all the specifications are stored in your Git repository, you can also see how things are changing over time. You have full version control of your specifications.
But OpenSpec isn't doing anything novel. It's just writing.
Organizing,
It's writing
product spec.
It's writing Gherkin, which is a tried and true way of specing.
Yeah. So here you can see, like when I did that OPX propose, it's asking me, are you doing a new feature, building something from scratch? Are you doing an enhancement? Are you doing a bug fix? Like, what are you doing? So I can say, like, I'm building a new feature. And now it's going to start writing out the specifications for that.
Great. Thank you.
Thank you all. Okay.